Good afternoon everyone. So my name is Nishant. And he's my partner for this session today. We'll be talking about a small tool that we developed called ra.2, and it's kind of a sequel to ra.1. And my friend is a very great fan of Shah Rukh Khan, so that's the name. So this is the reason we had this name. So this is basically a DOM-based XSS scanner, and of course we all, if you have done quite a bit of web pen testing, you might have used a tool called Dominator. So Dominator is it's a different tool, and what we like to call introduce a tool to you as it's the DOM-based XSS scanner for the rest of us. Okay, so who am I? My name is Nishant, and I'm an application security enthusiast. I presently work as a security engineer at Yahoo, and I was in past, this is my second company. Previously I was working for eBay, and I love to express my views on my personal homepage, nishant.com. And when I'm not hacking, I love to play electronic keyboards and love to cook. And I would like to introduce my friend Sarathi. He's an application developer, web application developer to be specific. He's a senior software engineer at Yahoo too, and as I said, a die-hard Sarathi fan. So, what is the agenda for today is I'll just briefly introduce or talk about what is DOM-based XSS and its relevance, and how to test manually, and what is our proposed solution. And we'll then introduce a tool ra2 and some of its USPs, and we'll have a case study and compare and see where it stands with when it compares with Dominator, and what are the future plans we have for it. So as you know, DOM is a way, I would say explain it in a very simple language. It's a way where you can manipulate the structure of a page in real time, and then it's like what is every other modern web application is using today. And when we're saying modifying or manipulating the DOM, we are talking about JavaScript, obviously. And JavaScripts, application developers, they often use JavaScript to modify the DOM based on user inputs, and these inputs can be evil. Right, so when we talk about inputs, we mean URL parameters, XHR responses, HTTP headers, etc. And the reason DOM-based XSS has become independent talk on its own, because of the thing that all the server-side validations are not applicable to DOM, protecting DOM-based XSS. So how do you go about dealing with DOM-based XSS? And the thing is, it is equally dangerous as reflective and stored XSS. And one more interesting thing is that most of the integrated XSS filters in IE and Chrome are not protecting against DOM-based XSS. So that before going deep into our tool, I'd like to explain you some of the key terminology that we'll be using again and again. First one is called sources. Sources are the points or the entry points that a user can control, and through which he can send his payload. When I say sources, they can be a very good example would be the URL, the parameters. We'll talk about in detail about it later. Since you say think of it as it's a box where you can execute a code. Your user inputs can be interpreted as JavaScript code and they can be executed. And filters are the operations, or say simply speaking functions that might change the content or check for specific structures of values. So let us go in deep with what are sources. I'll explain by giving examples. Everything that is taken from the URL document or URL document or URL unencoded location name, location, path name, href, search, hash, window location, path name, similarly href, search, hash. And these are some of the direct sources, what I mean call it. Indirect sources are like the referrer, what is the referrer header, the header, and the window.name, and many more. But did you get a pattern here? All the sources that I've talked are generally, are actually get parameter from the, you take it from the URL. Why not be interested in post variables? Anyone?
They're not the DOM.
Sorry?
They're not the DOM.
Yeah. So when you submit a form, right, you'll always have a server-side validation you can perform on it, right? So we are not interested. And yeah, so sync is every functionality in the browser or HTML that will actually create HTML. Say inner HTML, outer HTML, right? Document.write, we're doing a JavaScript call and writing directly to the DOM. Every functionality that will interpret a user input as JavaScript codes. It's like the functions like eval, exec script, function, set timeout, set interval, script.show, iframe, similar, lots more. Okay, so let us talk about this. So take a look at some example pages. I have actually created 6-7 example pages. These are not like real, these are just to test. So, so you see the red line, the line number 3, this is where we have a sync, right? And you see there's a variable here called parameter, short param. So everything that is, what we are doing is basically we are splitting the URL and taking the first object of the first element after the hash, and then we are just writing it up. So here, a pretty typical example like this. We can inject a script tag and execute JavaScript. This is one a second example. This line number 5 is where we have a sync. Basically, we're doing pretty much same thing, but just a bit modification. On the body onload event, we are calling a function fire, and the fire has, we are splitting the same thing, taking the first element after the hash, and then passing it to another function. And this function is actually, using the user input as an argument to the set timeout function, and this will eventually end up in code execution. This is one more example, a pretty simple example of a redirect, splitting and taking the first element after the hash and then doing a redirect, but then we can also anyway always inject the JavaScript colon alert. This is one more example. We are taking the user input and appending it to the body node of the DOM. So we have a body and then we have a div and we are appending it to the div. And this is again a popular example of redirect. You have a page and you see add banners, and then you see a surface site within the page. Mostly you see it on like ad revenue sites, URL shortening, stuff like that. So this is again the same thing. So okay, so let's go to the demo here. Okay, so so this is the test page I have uploaded to my own site. Now if you see here, what I just do here is I'll got an XSS. This is Firefox. So let us try it out on a browser that has some integrated XSS filter. I don't know how do I. I think there is a resolution issue.
Or maybe you can type it in a notepad and then paste it.
Yeah, that's good. So this.
Increase the font.
Right, so this is something we did for Firefox. Let us try it out on Chrome. I'll show you typical examples where this XSS filters fail. So you got an XSS on IE, but not on Chrome. But see, there are a couple of other vectors that will lead to a XSS issue on Chrome as well as on IE too. All the different I'll go one by one. This is the second URL, and since an example, what we do is we'll just okay. So it took 3 seconds. So we have a set timer for 3000 milliseconds. So the XSS is working on Chrome as well as on IE. So this is, I just wanted to show you some of the example scripts manually. Okay, so now it's time to come to our tool. Before that, some history. DOM XSS is not actually new. It was first talked about or first published paper that I read was by Amit, and where we are interested now is code now is now shifting towards client side. We have Ajax, Web 2.0, React, and if you have a RAID dominators block, 56 out of Alexa top 100 sites are vulnerable to DOM access. Though I did this survey, but he claims that integrated XSS filters in browsers, as I've said already, are failing to filter DOM-based XSS, and server-side input validation is bypassed. So that doesn't come into the scene, and it has the same impact on your users as regular XSS, maybe persistent or stored. And why we are interested in writing this tool is because what I know Dominator to be the only tool that tries to solve this problem to some extent. Do you agree? Okay.
No, not really. There is also iPhones.
Okay, so to test DOM XSS manually, source code review is the best way. But kind of this is a bit tough, I know. So what can be the possible solutions to solving this problem is we can go about writing a static analyzer. It's very good at finding flows, and if well implemented, it's very fast actually. But what I know a limitation is static analyzer. It has a knowledge base and lack of runtime analysis and a lot of false positives and negatives, etc. Dynamic analyzer, yeah, you use an interpreter, so no problem with obfuscation or compression, but you cannot control the flow. It's like a black box scanner. You know that the page is vulnerable, but where I need to make the patch, I don't think dynamical. So what if we can mix the two things? So what is the idea behind our tool is, what we have done is we have taken, since our tool is a Firefox add-on, so it uses the native Firefox JavaScript engine for JavaScript interpretation. So compression obfuscation is all handled by the Firefox engine. We don't have to care for it, and we do black box fuzzing. So as I said, it's a tool for the rest of us. So we need to we supply the 1,000 of URLs and run it overnight, and then you come back with a report. And there are some things which need manual intervention to trigger the XSS. So we have implemented partial browser automation, so to simulate human events or to trigger events. So automation and black box fuzzing, we think it's a win. So as I've already introduced to you, Ratu is the code name for tool, and he's a fan of, my friend is a fan of Sarukan, so Ravan is equal Ratu. Ratu is a Firefox Mozilla add-on, and we use Firefox JavaScript to dynamically execute vectors and inject possible, locate sources and sinks, and locate exploitable DOM-based access. Okay, so this is how it works. In the step 1, you initiate a scan. In step 2, our tool has right now is offer, you can scan a page or you can scan a list of URLs, depends upon you. So say suppose you are scanning a page, single page. When you initiate a scan, and after the page gets loaded, loading is done, our tool will inject our own custom JavaScript code as a .js file and inject it to the head section of the DOM. If a head is already there, it will inject it. If it's not there, it will create a head tag and then inject. And the third step, it fuzzes all possible sources. Like possible sources, I think so far we have implemented only for the URLs, because that is what the mostly people use to exploit. We have not implemented this exploitation through headers, referrers, or any cookie headers. It fuzzes all possible sources with our custom callback, and so if our code is directly executed by the browser, like say it slides down the sink and then boom, so the URL of the page will be recorded in our database. If it's not, if it's require an event from the user to trigger it, we have implemented some partial event handler to trigger the event and trigger the callback actually. And to be frank, we have taken this event and list of event handlers from Dominator actually. And once our callback executes, it generates XHR response to our database. And this actually, in our case, it's our database. You can configure it to be your own database so that you don't end up sending your vulnerable URL to us. And at the end, you see a nice report, and where you can manually actually verify whether it's exploitable or not. So, if you have understood the concept, how this tool works is, we are actually calling our own callback and then recording the URLs. So only if our callback executes, we record the URL. So by design, it is made to be false positive free. And so hence the URL is exploitable. We have a large collection of injection vectors we have collected from multiple sources, primarily from Arsenex's vector list, and we have modified everything. So modified in the sense, we are wondering about what we modified it is in the typically the XSS vectors, they have this script alert thing. So you visually see there is an XSS, but since alert is a Windows modal dialog, we were not able to automate, because we need to click it, and automating the modal dialogs from the browser was a challenge for us. So what it did was, we replaced alert and replaced alert with our own callback. So it will not show up any pop-up or something. It will just record things what we want it to, and it supports transforming characters. So I'm sure you must have tried the Fiddler plugin called XSS. You have Unicode characters which translate into some evil characters, even though you have filtered it out, like the big the angle brackets and stuff like that. So we have included all those things. So we tried to make it as much comprehensive as we could make it to. And since, as I've told already, since it's a browser interpreter, we handle obfuscation and compression, and it's pretty easy. You just have a point and click tool. So yeah, now comes the case study. After that, we'll have a demo of the tool. Dominator versus raw tool. So this is how most people take, but we don't see it as a versus. So Dominator is a gray box scanner, whereas our tool is a black box scanner. Dominator has runtime tainting and somewhat runtime code flow analysis. We do basic browser automation. For Dominator, you need to be very good in understanding JavaScript and DOM-based XSS, and you need very niche skills to actually use the tool and then get fruitful results out of it. We have designed this tool to be used by, we have made it, if you are using it for testing, it's so very good. But we have made it specifically for the audience, like the normal quality assurance testers who don't want to get into the depths of security and to understand how DOM access. They need a tool where you can point and click, and then they can figure out whether these their URLs are vulnerable or not. And so far we couldn't find any tool that was doing that, and it was free or open source for that matter. So yeah, so it's point and click, and since Dominator requires manual analysis, it is slow, and but we have designed it to be, since it's you just scan and leave the tool overnight. It's lightweight and fast. It's a standalone tool. Dominator is a browser in itself, but our tool is a Firefox add-on, so it has easier deployment issues in large enterprises, and we make it free for use for enterprise as well as personal use. And so the verdict is both are complementary to each other. They are not actually competitors. So now the time for demo of our tool. So I'll go back. Okay, so if you see here, we have some few test scripts uploaded. So if you see this 1 to 6 are the pages that we're going to scan. This 20 to 23 are the pages that our tool is not able to detect, and we'll discuss why it's not able to detect and what are the work that we are doing to make it detect in future cases. So for this demo, I'll just scan the 6 pages. So let me close all these. Here's my stops. Okay, so if you see, to save your time, we have just taken few vectors so that it doesn't take too long to scan and you don't get bored. So, but if you need we have the original vectors list. We have all these things. So you see all these hex encoded. These are all modified for our own callback. So this file is what our tool supports, and it has this Unicode characters for this transforming thing. So this is our own the custom callback that we're calling scan page. We can short it out for where we have a space limitation, like say 3-4 characters we can inject. We can short it down to some function shorter than this. So okay, so this is what our tool looks like. I know it's a bit ugly, but you have these 3 options. Scan this URL, scan from file and settings. Go to settings. You see you have an option to set your database IP where you want to record. Use password and the username. And you have there are a lot of other for now we have just implemented 2 options here. first all parameters and first each character. So there is a unique, interesting case that I came across was it's a website that I came across has a DOM access vulnerability, but if you inject the entire parameter, right, it will not trigger the XSS. But there is a certain point within the value of the parameter where you inject the payload, and I don't know what is the logic behind doing that, but it triggers the payload. So that inspired us to add this feature called first each character, so that so you provide a URL, it takes all the parameters, and then you have some default values, right, when you provide the URL, and it takes each character and then injects, say you have a parameter which has a value of 5 letters. So it takes each character and then injects the payload within, say, first and second character will inject the payload, then third and second and third will inject the payload. So actually this will take a long time, but you don't miss a vulnerability. And you can provide your URL list, part of the list of URLs that you want to scan. So we have here. So we have a just replace it here. So save. So that URL file here. Save. We'll go ahead and start scanning. We'll check this. So basically we are using a local database server, and the reason behind having a database is we wanted to make it scalable for large scale enterprise, so that multiple users, they don't end up having their own reports on their own local boxes, so that we have a centralized repository where you can anybody can grab and then list URLs. So by the time it scans, any questions so far?
Yeah, like you have a callback method for the scan. It can be anything else also.
Right.
But I mean, sometimes when you have when you're loading a page, the page also might have a function defined with the same name. So in that case, you might actually be tripling the functionality of the page in a certain way.
Right.
So do you check if there is a function declared with that name before you declare your function?
No, so far we have not done that, but
actually it is calling the function of our add-on. The add-on the scan page is created. So in the page it won't call the function of the DOM.
Okay, so you can have the same function name.
Yeah, it will call the function of the add-on directly add-on. It sits in the browser.
Okay,
So if you have any other add-on like Firefox, they have the scan page function, then it will not in the page.
so it's isolated kind of thing, the DOM and the. Okay, so when the scan is complete, you see something, a report like this. So you get all the. So these are the, say, there is a difference here. You see a column called URL. These are the normal URLs that are vulnerable and have been recorded in the DB. And there is another column called thread. So in thread, this column refers to those pages where our add-on was able to simulate a human and trigger an event. So here if you see, let us verify this thing. So if you click on this any URL, you can manually verify here. It will open a new tab. So here, you see what is the injected payload is, after hash you have injected JavaScript alert 1, right? And this particular hyperlink has been, or anchor tag has been poisoned. If you inspect elemented, you see in the href tag we have JavaScript alert 1. So for this to trigger, the user needs to click the hyperlink. But here if you see here in the thread, it's automatically recorded. So you see this our tool has been able to trigger the event for us.
Is that done by just calling the click on the element? Element.click, is that how you did it?
Yes. So we have event handlers, like we are iterating through all the elements in the DOM, and then looking for all the on-star events, on-publish, on-blur, href, and which will have our can take inputs and then execute JavaScript, and then we execute. If we find our callback is poisoned in an element, just call it and then record the URL. And if you take this one and then manually verify it. So since it was a normal URL, it injected from the URL and it got executed directly. So here you have an option to say you want to deploy it for a team of QA engineers. You can specify what this means, like what this image tag means and what is the fix for it. For now we have just left it blank. You have the option to add any comments you want to add.
So are you planning to add spidering to it as well?
Actually, since it's a tool we developed in-house in our company, so we have a add-on that does spidering. So we have integrated it. But when you're planning to release it to the public open source, we can include a spidering engine to it.
Or in fact, if you spider through both, you can just export all
Right. We can import a CSV or XML for that matter. That will not be a problem. Because anyway, we are importing a text file, right? Separated by a CRLF character, and you can do it for any file for that matter. Or we can provide options for you to specify your own list file. So since Dominator is the guy, Stefano was the guy who did this Dominator, so I was really curious to know what Stefano has to say for this tool and get a review from it. So this is what he has to say, and this is not an endorsement. So I think we are at the end of this session. The summary is our tool. We believe our tool is pretty much able to detect low-hanging fruits, and it's a work in progress. Like other automated tool, it cannot detect all issues. So I'll show you what all the other issues are, just to get you the idea of what we are facing the challenge right now, and some of you might be interested to contribute to it provides us some tips on how to go about solving it. So this is so one issue is we are facing is browser dependent XSS. Like there are some XSS conditions dependent on IE or Chrome. How do we write a Firefox add-on and then detect all of them? That is the one issue. This is a very typical example which works with IE6. This is the code for it. Basically, you're taking an image file and then setting it as a style background image in the URL and inject a JavaScript alert one. Yeah, and then it would execute on IE6. Sorry. So this is one thing, and the second thing we're facing a challenge is referrers, referer headers. Obviously, this is not a challenge right now, but we have not implemented this thing. By the time we release it in a month or so, we'll be implementing this referer headers and cookie headers at least. Yeah, so this is again no, I'll show you the code. So this is again a test case where it's working on IE only. So ignore it's a mistake we have done. It doesn't work on Chrome, but it works on IE where you just document it right and provide this as a parameter within the option tag, and it would execute. But it won't work on Firefox or Chrome or Safari. And the last thing is yes. So the last thing is, so when our callback is directly not a value of an attribute that we are actually iterating or looking for in the DOM. Say there is a second function which calls our callback. So in the first iteration we will not find our callback and we will mark it as false positive. As clean, but then it will not be clean. So for that thing, the only solution to this problem I can see is runtime analysis. You see, you have an iframe here, and this is a typical example. This content is not served from a website. Are you sure you want to view this content? And when you do yes allow, this hyperlink has a function called reload. And in this reload, this function is actually calling whatever there is after the hash in the URL. So when you are iterating to the DOM and we get a hyperlink and we look for the attribute href, and we see JavaScript reload, which is not scan page. So in that, the first case it will not call out the callback, but then this page is vulnerable. So this is one thing. So runtime code analysis and browser dependent issues are the two challenges that we are facing right now. But apart from it, so far we have tested, it works fine, and then you guys can help us with more testing. And like any other tool, this is not a replacement to manual penetration testing. So what's next? As I told, we are looking for a solution to detect browser-dependent DOM-based access issues, better browser instrumentation, runtime code flow analysis. This is going to take quite a lot of time, and better reporting. And of course, give suggestions. If anyone has a suggestion for us, we can say it now, or you can drop a mail to us.
See, that browser support thing, individual payloads, see, there is a vulnerability in the option tag. The option tag, if there is a DOM access, only the IE it will support, but Chrome it won't. So if someone could develop a dictionary-based set, a rules which define that this is the payload for Internet Explorer, and there might be a bypass for Firefox, or there might not be. So when you display the results, this is for Chrome and this is for Firefox. But it will take some time in developing individual signatures actually. But if you have a previous set of outputs, then you could, someone could manually test it. Then we could make a dictionary. So later when people test it out, that display could be, this is for Chrome, this is for Firefox, or there is no bypass for IE. So that way you could display. Should be a signature database.
I think there is a project which is now discontinued. I think there is a it was started by Jeremiah and John. They created a table where you have all the browsers and then columns, and then you have tags, and then which browser has a code execution on which tag and which event handler.
That has DOM XSS wiki. It has that which character.
Right, but yeah, they have included the tag, but for the wikis has been developed, written for say 4 or 5 tags so far. Not all the tags are written. They have been just listed.
To log out the user, right? So you think doesn't log the user, otherwise the rest of the test will work. So I can add.
I didn't get it.
Let's say there is a function in your DOM that should log the user.
Okay.
Right? So if you will give me a blacklist, I can put this function in the blacklist, so that you think does not call the event.
No, actually we are not actually calling the functions or event handlers for all the tags, and only if we find that any tag has an attribute that contains our callback in it as a value. We just call it. We're not calling each and every functions on the DOM, so that we are not touching the logout functions for that matter. Better reporting, yeah. So we are done. So I would like to thank Stefano for this pretty since we have exchanged a lot of mails for this tool and feedback and brainstorming. I would like to thank my colleague Vishan, he's not here today now, and one more colleague Daniel. So if you find this thing any of even a little of use to you, just write a drop to them. They have helped me a lot to go through it and actually make it happen. And finally, we are done with this session. And any questions, any feedbacks, any flames you have, we'd love to take it. All done.
When it will be available?
We are planning to actually we have some documentation things left, and we are planning to add those things, and then by this month I think we'll be able to release it. Thank you guys for your time.